get started on this here. Are there questions on problems 1 through 8? 1 through 8. Any one of these 8 that y'all want to look at or see? We're good with 1 through 8? So I'm just going to pick one. Well, negative 256 is less than x is less than or equal to 100. So negative 256 is the smallest number. 100 would be the biggest. Since it is just less than, it's not equal to, we would use a parenthesis. Since it is equal to 100, we would use a bracket. So this would be the answer. Now, if we only have, like number 2, x is less than 200. So since we're talking about less than, it is smaller. So 200 would be here, and we would have a parenthesis because it is not equal to 200. And on the other side, we would have a negative infinity. Because when we only have x is greater than or x is less than, most likely we're going to have an infinity or a negative infinity. So, and again, making sure to have the correct parenthesis or bracket and making sure the numbers are on the correct side. I do attribute points to both. Any other questions on 1 through 8? If we're good with 1 through 8, questions on 9 through 14. Any one of those in particular that you want to look at? 9 through 14. Number 9. So here we're wanting to write it in set builder notation. Now, since we're talking about an interval, we're just going to say the set of all real numbers x. So our curly bracket x bar is the set of all real numbers x such that, well, unfortunately, I can't just put this in as it is. I need to change it over to inequality notation, into an inequality. Well, since I have two numbers, I don't have infinity. Most likely that means x is going to be in the middle. Our smaller number is negative 24. Our biggest number is 24 equal to, is x equal to negative 24? No, so we just have our less than. Is it equal to 87? Yeah, because it does have a bracket. So this would be the inequality. So we can just plug it in. Negative 24 is less than x is less than or equal to 87. So any other questions on number 9 before we look at 13? You ready to look at 13? 13, 6 comma infinity. So if I wrote this as an inequality, it would be what? X is greater than or less than 6. Because we're talking about the interval from 6 to infinity. We're talking about the numbers getting bigger, so the inequality would be x is greater than 6. Set builder notation is going to be the set of all real numbers x such that x is greater than 6. And that's it. Any other questions on 9 through 14? Are we good with 9 through 14? Yes? If there are no other questions on 9 through 14, let's look at 15 through 18. Which one of these do we want to look at first? 15. So when we look at this here, if we want to do this by hand, I can pick an eliminator equation or eliminator variable. Which variable do we want to eliminate first? Why? 5y, 5y, 5y. Let's pick y. Now, it doesn't really matter which one we pick as the eliminator equation. I'll pick the bottom one. So negative x minus 5y minus 5z equals 2. 4x minus 5y plus 4z equals 19. Well, since the values of y, the number in front of y is already matched up, we can just go on and put it underneath. Any questions on how we set this up? So let's look at the one on the left. So we have negative 5y on top, positive 5y on bottom. So would we add or subtract? Well, we can always check it. Negative 5 minus 5. Negative 5 minus 5 would be negative 10. Negative 5 plus 5 would be 0. So we're doing these here, either way, when we add or subtract, just go on and actually do the addition and subtraction. Don't just assume they do cancel out. Negative x plus x is 0. Negative 5y plus 5y is negative 5z plus negative z is negative 6z. 2 plus negative 20 would be negative. Hey, we already have just one variable. Let's finish it. Z is equal to positive 3. That's kind of nice. Let's check the other one. So here we would add again because we have a negative and a positive. When they're opposite, we add. 4x plus x is? Yes, 5x. I don't know why I wanted to say 6. 5x. Negative 5 plus 5 would be 0, just like we want. And 4z plus negative z plus 3z is equal to 19 plus negative 20 is negative 1. Well, 5x plus 3z equals negative 1. I already know what z is, yes? Z is 3. Let's plug it in. 5x plus 3 times 3 is equal to negative 1. Well, 3 times 3 is 9. Then we would minus 9 from both sides, telling us 5x is equal to by and get almost negative 2. So we have two of the variables. We're just missing the value of y. Now it really doesn't matter which equation we get. X plus 5y minus z equals negative 20. I just picked one of them. It really doesn't matter which one we pick. All of them should give us the exact same results. Well, x is negative 2. Plus 5y minus z is 3 gives us negative 20. So really we have negative 2 plus 5y minus 3 is equal to negative 2 minus 3 is negative 5. To solve for the value of y, we add 5 to both sides, which tells us divide both sides by 5. Y is equal to negative 3. So our answer is negative 2, negative 3, and 3. And that there would be our answer. Any other questions on this here? How else could we have done this? We can type this onto the calculator because we can put it in as a matrice, done our REF, reselected that matrice, hit enter, and it would have told us down the side that the answer is negative 2, negative 3, and 3. Any questions on this here? Now, what does it say up at the top in the directions? Solve each system by augmented matrix. By any method, yes. Solve each matrix by any method, but you might want to be able to solve one by hand. So there might be a bonus question where it asks for this here. But if it asks to solve by hand, that's It's nice if you get the answer, but what is it really asking for? Everything else. It's not really about the answer. You need to get the correct answer, but it's really looking for everything else. So if it does say by any method, the calculator is a correct method to solve. As long as you don't use your neighbor, any method does work. Any questions on this here? Are we good with 15 through 18? Because they would all be the exact same. Questions on 19 through 24. 19 through 24, is there one of those that y'all want to look at? Let's do 20. So one of the big things with augmented matrices is that all the variables need to be on one side and the constant numbers, the numbers without a variable, are on the other, yes? What else did we have? It had to be what? Alphabetical order. So here it's going to be X, Y. So if I look at the top row, X goes first. We don't have Y, then we have Z, then we have a number, yes? So it's good. How about the next one? Well, we need to flip the Y and X, yes? But Z is fine, number is fine. Last one, X, Y, Z, number. So we're pretty much good, yes? So if I was going across the top for the top equation, well, we would have 6 for the X and then 2. Now the next equation, we said the X and Y were switched, yes? So what number goes with X? And it should go, and then 4, and the last one to be 6, -1, 3, 20. So I could have rewritten that middle equation and then had them flipped, or I can just flip them when I augment the matrix. It'll do the exact same thing. Do you have any questions about writing the augmented matrix? What's the dimensions? 3 rows, 4 columns, so it is a 3 by 4. And that's it. This problem here, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, 6, 7, is worth 8 points. Again, I make each element worth half a point or so. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. So the elements themselves are worth 6. The dimensions is worth a point. 7, and you get 1 point for work. So especially on stating these here, stating the dimensions and writing the augmented matrix, I would make sure that you put them in the correct order, because having two flipped, half a point, that's a whole point for having two in the wrong order. But any other questions on this here? So here we have X and X, Y and Y, yes? Do we have a Z? Does it show up anywhere? 7, -41, 29, 46, -2, 19, and this is a 2 by 3. Because how many times does it need to show up for me to include it? Once. If it shows up in one of the equation, it needs to be included in the others. But if it does not show up in any of the other equations, if it didn't show up at all, we don't need it. It's not included. Any other questions on this here? I think we're good with those. I think that's it, isn't it? Or no, there's a random blank page before we hit 25 through 29. Are there questions on 25 through 29? Yes. Which one? For all of these here, because our horizontal translations, our left and right, was y equals f times x minus h. Our vertical translations was our it was our y equals f of x plus k. Our horizontal stretch or shrink was our y equals f of a times x. Our vertical stretch or shrink was our y equals a times f of x. Our reflection across the, let's see here, yeah, y-axis was really talking about y equals f of negative x, and our reflection across the x-axis was our y equals negative f of x. These here are what I would go back to every single time. Whenever we're looking at any of these here, I would always, and you should always refer back to one of these here, because it's always going to come down to this. Okay, we're good. Okay. So, translated up 3 is the first one, yes? So really, I'll call it h of x as a middle step. Well, that would be our f of x plus k, because that's our vertical translation up and down. So how far are we going? So it would be 3, and it would be still positive, because up is positive, down is, well, what is f of x? 6x squared minus 1. So all I did was replace f of x with the function itself. Well, we can drop the parentheses because we don't need them, yes? What's negative 1 plus 3? And it would be positive, yes? So we move the function up 3? Well, yes. Okay, so that's done. And what's next? A vertical stretch of, so that means our g of x, our final function, is going to be what? Following our a times f of x. That's our vertical stretch and shrink, yes? And our factor would be just 2. Because the only time we have to do something funky is if it is horizontal stretch or shrink. Really inside the parentheses, then we've got to do something a little bit tricky. So here it's just going to be 2 times our function, h of x. Because we're not worried about the original function anymore. We're worried about the one that we translated up 3. Now what is h of x? And what are we going to do? We're going to multiply through by, well, 6x squared times 2 is, 2 times 2 is, that's it. So with all of these here, trying to remember all the steps and how we do them in our head is a bit much. So again, going back to our y equals, these setups is going to make these a lot easier. Because we set it up f of x minus whatever we're moving, left or right. And again, when we move left or right, just go on and plug it in. Because if it's x minus left 3, we'd say x minus negative 3. Negative, negative would make a positive. Or if it's right 3, it would just be x minus 3. Another one y'all want to look at. 26. Translated right 4 and up 3. So we'll call the middle function h of x is equal to f of x minus. We're going right first, yes? So h would be? Yeah, it would be positive 4. But inside the function, it's going to look like x minus 4. Because the value of h itself is a positive 4, but because of how our notation is set up, it's going to be x minus 4. If it had been left 4, we would say x minus negative 4. And then we could rewrite it as plus. Now, this time, we don't have f of x anymore. We have what? F of. So that means in the function f of x, I need to replace every x with x minus 4, because that's what it did. It's not f of x anymore, it's f of x minus 4. So what we'll have is 2 times x minus 4 minus 1. Well, we do have something in front of the parentheses, so we will have to distribute. 2 times x is 2 times negative 4 is, and negative 8 minus 1 is negative 9. Any other questions on this here? Right 4 is done. Now we need to do what? Up 3. So our g of x, the final function, well, vertical translation would be our f of x plus k. Where are we moving? Up 4, yes. So our value of k would be plus 3, because we're moving up 3, yes? If it had been down 3, we could have said f of x minus 3. Or sorry, not f of x, it should be h of x, because our middle step is h. Now what is h of x? The absolute value of 2x minus 9, and then we have our plus 3. Well, that's just going to be the absolute value of 2x minus 9 plus 3. Because the plus 3 will not go inside the absolute value bars. And that's it. Any other questions on these here, these transformations, up, down, left, right, vertical stretch, horizontal stretch and shrink, or our reflections? So questions on 25 through 31. Is there another one of those that y'all want to look at? Okay. 27, 28. So again, I'm always going to just take it one at a time, reflected across the x-axis, then translated up 4. So h of x would be our starting one. Reflected across the x-axis is going to be our negative f of x, because that's the one that is connected with our reflection across the x-axis. Well, what is f of x? Well, it's the absolute value for x minus 3 plus 2. Now this time we do have a negative outside those parentheses, so it does need to be distributed across. So it won't go inside the absolute value, so it's just going to be negative absolute value of 4x minus 3. But a negative times a positive would give us negative 2. And then we translate it up 4. So we're going to use our g of x equals h of x plus k. Our k is positive 4, so it's just going to be plus 4. And again, at this point here, we can plug in h of x well, the negative absolute value of 4x minus 3 is not going to change. But the negative 2 plus 4 is going to become what? Positive 2. Any questions on this here? So with a lot of these here, it's just taking them one transformation at a time. Because if we take it one transformation at a time, it makes these a lot easier to work with. Any other questions on these here? We good with these here? Any questions on 29, 30, or 31? Questions on 29, 30, or 31? We good with these here? Okay, if we're good with those there, we'll move on. Questions on 30 or 31? We good with 30 and 31?
30 and 31 are different numbers.
Yeah, the numbers are different, but the problems are the same. Because I added 30 and 31 in for the horizontal stretch and shrink, so it bumped everything down too. I didn't take the time this morning to renumber this. This is the old sheet without those. So any question on these two here, our first two with our matrice operations? We good with these here, multiplying by a scalar, addition, subtraction? Because we can also do what? We can plug these into the calculator. Because 30, we're just multiplying each element by 1/4, which would give us 4, 6. And that's it. Here we would just combine the like elements by addition or subtraction. Questions on these two here? Correct. Because? So 3 by 3 and a 3 by 2. The dimensions have to be the exact same for us to be able to add or subtract. Any question on these two here? We good with all the matrices? Okay. Questions on number 38, 39, or 41? 39. So we want to find the equation of the line, yes? Well, slope is our y2 minus y1 over x2 minus x1. So what are the two y values they gave us?
90 and 40.
Because y always comes second. Our x values would be 40 and 15. Now at this point here, we can plug this into the calculator and have it figure it out for us. We don't have to solve this by hand. But if we did 90 minus 40 is 50. And 25. And 50 divided by 25 is 2. Now they didn't give us the y-intercept, but we can use our point slope equation. Y minus, well, it doesn't matter which point we pick because they will give us the same thing. 40 is equal to 2 times x minus 15. I'm just plugging one of the points in. Now we'll get it to y equals mx plus b. So I'll multiply both sides by 2. So 2x minus 30. And last but not least, we would add 40 to both sides, which tells us y is equal to 2x plus. And then it asks for us to interpret the slope or describe the slope. So for every minute practiced, he throws, T-H-R-O, throws 2 pitches. because our slope is 2 over what? So since the x value is minutes, so minutes would be 1, 2 throws. If we wanted to say for every 10 minutes, it would be 20 throws. Any other questions on this one here? We good with this one here? Question on 40. Is there a slope for this here? No, so m is equal to? What's the y-intercept? So this here is just y is equal to? And really, we're just saying that the car is staying at a constant rate of 65 miles an hour. It's not changing. And that's it, isn't it? Are there any other questions on any other part of the review sheet that y'all want to look at, or anything we didn't look at? These? Sure. We just start at the top. Horizontal translation of 4 units left. If we've got 1, 2, 3, so I'm just going to say g of x, it really doesn't matter. So 4 units left would be x minus negative 4, because our value of h would be negative 4. Well, a negative and a negative would make a, so really we have x plus 4. So let's apply it first. So we start off with f of x is equal to 2 times the absolute value of x minus 3. Well, I don't have f of x anymore, I have f of. So I need to replace it. So we'd have 2 absolute value of x plus 4 minus 3. Well, there's nothing in front of those parentheses, so we can kind of just drop them and do plus 4 minus 3 is plus 1. Horizontal translation of 4 minus 3. Okay. What's our next one? Vertical shrink of 1/3. So this here is going to our h of x is equal to a times g of x or a times f of x. Since it's vertical, we're just going to say 1/3 times g of x. Because vertical stretch and shrink, it does not change. Then our function g of x is 2 absolute value of x plus 1. Any questions on how we got to this point here? Well, what do? We would just distribute the 1/3 all the way through. Well, it's just multiplying it by this here, which would be 2/3 times the absolute value of x plus 1. I'll scroll down just a little bit. Vertical shrink. So is that it? Okay. Let's just call it m of x. It really doesn't matter. Now this is a horizontal stretch, so we're f parentheses a times x. So it says the factor is 4, so what number do we put inside? Because remember with vertical stretch and shrink, we have to flip it. So if it's 4, its flip or its reciprocal is 1/4. So this here, sorry, it's not f of x, it would be really h of x, h of 1/4 x. Really the notation doesn't matter too much. It just kind of helps us realize we're talking about this function not down here, not the one we started with. So what we're going to do is we're going to replace every x with 1/4 x. which really just tells us that the function is 2/3 times the absolute value of 1/4 x plus 1. And that's it. Any other questions on this here? Yes. Any other questions on the review sheet or anything else you all want to look at? We good with this here? Okay. So on the other one.